Let's get started. To my left, I've got the real talent. I'm going to be asking them some questions, and then we're hoping to stimulate some conversation that you can participate in. I'm Dan Turchin, and I am from BigPanda. Big Panda. I'm one of the smaller of the pandas. We are a data science platform for correlating noisy alerts. So for about a dozen years or so, I've been on this crusade to solve the noisy alert problem.
Here.
Yes, that has plagued us all at one time or another. And when I met the team at BigPanda when they were just starting out, almost literally two guys and a dog in a garage in Tel Aviv, I was so inspired. I was at a big startup called ServiceNow at the time, and we were looking for a better way to automate noise suppression, and met about 40 different companies that were doing all kinds of interesting things in and around the noise suppression automation space. And when we ran all those products against kind of the same battery of tests, we compared the results from a set of human operators at our NOC in Kirkland with what all of these automation algorithms could do, and against that kind of scale, the BigPanda algorithms came out about an order of magnitude better than anything else we had seen, about 95% noise suppression. I was pretty intrigued. I joined the team. That was a couple years ago now, and it's been a wild ride. So anyway, I'll talk a little bit more about our approach, but for today's session, I wanted to make sure we get lots of time with my boy Termy here, who just took us to church, and Greg, who I admire the hell out of, because ever since I was at DevOps Days, Silicon Valley last year, Greg's talk, why can't we all be Kelsey Hightower, changed my life. So I'm really flattered to be on the same stage with these two gents. And to get us started, why don't, you heard from Termy already. Greg, why don't you introduce yourself real quick?
Okay, so hi, I'm Greg. I am the CTO at Opsee. I have like X many years of experience in operations and DevOps and software engineering. I really like monitoring a lot for some reason, because it's like fault detection, right? Like you have a thing and it's supposed to be working, and the idea is that you want it to work as much as possible. So part of that is understanding when it breaks, and then understanding why it breaks. And I really enjoy the process of figuring out why it broke and then making it not break, and then also detecting other ways that it can break. Anyway, yeah, so that's me. That's what I do a lot.
A lot of us were at Monitorama last year in Portland, and one of the most interesting talks that I recall was one from a guy named Tony Rippey, who's a manager of SRE out of the New York office for Google. And he got up there and told us about the monitoring journey at Google. And one of the things he shared, one of his slides, was the very first monitoring strategy at Google. And it was all of a 3-line Perl script that did exactly two things.
How long was the line?
It's like 4,000 characters per line.
Google it. It did, what's that?
No.
Was he? If he was then, he probably is still now. I don't know. I think the answer is no. But it did two things. It would ping google.com, and if google.com didn't respond, it would ping yahoo.com. And that for like 4 years, that's how Google was monitored. So my question for you, so as we think about this kind of IT ops journey that we've all been on, the first thing that came to mind for me, thinking back to all the years that I spent carrying a pager, that I'd like to get the real expert's perspective on is, so channel your inner Tony Rippey. Tell us the story of the early days of monitoring and what it was like before we had some of the tools that we have today.
Sure, I'll start. I'm terrible at monitoring. I'm the
I can help you with that.
Yeah. So back in the day, I had the glorious position of being the only ops guy on the team, and also the lead dev, which is cool in some ways because you can sort of solve your own problems in unusual ways. I also happen to fly often, so I'd be on an airplane pretty often, and I had a pretty good habit of every single time I got on an airplane, a service would go down. So as soon as I landed, I had to immediately rush for Wi-Fi in whatever country I had just landed in and attempt to get our stuff back running. In almost every case, that required restarting a service. So my solution was a cron job that restarted every service every 30 minutes. If I'm out drinking and it's 2 a.m. and I get a call, the very first thing, like somebody says, "Oh man, the service is down." By the way, that's our monitoring. It's like the CEO finding out and then texting me. Was basically saying, "Okay, cool, I'm on it," and then having another beer, because yes, I just wrote all of our services such that it was easy enough for them to restart without losing any data. It was all very queue-based at the time, and the database wasn't often going down. When that did, it was obviously a little bit more difficult. But everything else, cron job, every 30 minutes.
Nice.
So monitoring.
Yeah. So I've actually used a computer. Sorry. No. So, okay, but for real, when I first started, I was working at an internet service provider in like 1999, back when dial-up was still cool and we didn't have text messaging. And this was like, yeah, I know, no text. I'm really old. I look beautiful, but I'm really old. So I'm at least 25. So yeah, we had this thing called Big Brother, and I think it's actually still around today.
TV show?
No, not the TV. This is before TV. So we had this thing called Big Brother, and everything had 4 health checks. Every machine ran one thing, which is still common today. But every machine had 4 things. It had a ping check to see if the machine was alive. It had a CPU check to see if CPU is above X%. Like, none of this that you're doing is new. It had memory checks. It had disk checks. It 5 things. It had a process check. And whenever any of those things would go red, somebody on the 24-hour sysadmin team, by the way, so I worked grave shift for like 2.5 years as a sysadmin. We would see the thing go red, and then we would SSH to the machine and restart it, and that was monitoring. Yeah, that was the beginning of monitoring for me. It was a sad day. Some years later, I got to build real things that were not terrible and not depressing. And so when I was in college, we had batch jobs. I worked in a data science lab at Auburn. Anyway, so yeah, we would have these batch jobs that would run in the distributed computing lab, and then when they were done, we'd have to analyze the results, blah, blah, blah. It's for some guy's master thesis. And then if the batch job failed, I had written a thing that would text me at the bar, of course, and I could actually respond and be like, restart. And yeah, yeah, exactly. That was this was, so I had a stint of college after a beginning of a professional career. So this was 2000 and, when did I go to school? 10, 11 or so, something like that, yeah.
So this week was a tough one if your last name was Benioff. And question for the panelists is, let's say Mr. Benioff of Salesforce.com fame calls you up and says, this can never happen again, right? They had a very high-profile outage. We were affected. Everyone else was affected. I was 24 hours or so of downtime. Catastrophic. So, Termy, Greg, so you get a call, bat phone rings, it's Mark Benioff, and he says, save me. I'll write you whatever size check you need. Make sure my site never goes down again. What's your process? How do you analyze? how do you do a postmortem, and what coaching do you have for Benioff?
Hire Greg.
You're doomed.
Mr. Who? Seriously, I would start hiring people myself. I would say this is, for something like Salesforce, that's a gigantic fucking company. I've had my favorite people I've worked with in the sort of ops space have been Google SREs. They have been, in my experience, by far the most outrageously knowledgeable about all these things that I've ever run into. I feel like an imposter compared to them. They're really quite interesting. I've had pretty good experience. I would definitely not take that on my own. If I were for some reason the greatest ops alive, and felt that I could take on that large thing, I'd probably start by asking them where their monitoring systems are and trying to debug it. I had some pretty good experiences with sysdig recently, which was quite interesting. So I'd maybe get people to run that on some of the machines that were affected if they were still SSHable. I really don't know anything about this outage though, because I'm not a Salesforce user. So I'm not sure where to start. I'd be very pragmatic, I suppose.
Great.
Yeah. So I also, I only heard about the outage. It's like, oh, Salesforce outage. That's juicy. I'm going to tweet about it. Regardless of the component of Salesforce, right, that was down, a lot of this boils down to understanding your failure domains, right? And that's one of the key components of monitoring is okay, so I have to admit that I recently started reading Mark Burgess's book on promise theory. And the idea is that you say, I'm going to promise to do something. And simply by saying I'm going to promise to do something, that makes you actually think about what you're promising to do. And so in promise theory, the idea is that it drives you to better understand ways in which you might fail to live up to your promise. So the goal of monitoring systems is to understand, what am I actually saying I'm going to do? And then understanding the ways in which you might fail to live up to that promise. And I think that, to promise something unreasonable, I will never go down, that's a promise you literally cannot keep. You absolutely cannot keep that promise. So from that, you then have to understand that if you accept that you will go down, you will have downtime, then it becomes a conversation of mean time to resolution. How do I decrease mean time to resolution to as near close to zero as possible? And the answer to that is understanding your failure domains and then making sure that you know when you reach that point at which a particular failure domain actually fails, right? I have this one component. I'm using Redis, right? Big mistake, first of all. I'm using Redis, and Redis went down, so now I know that. But I'm using auto-clustering Redis and InfluxDB. No, but seriously, you understand that there's a component that has failed, and you understand it failed and why it failed. That's the really important part, right? So what you say to executive that's telling you can't go down is well, actually we can. So what I'm going to need from you is support in this initiative to make sure that we have automation and monitoring in place to understand why we went down, the component that failed, and the action we need to take to remediate.
Given the fact that everything throws out millions of lines of logs, so how do you know what to look for?
BigPanda.
Yeah.
Is he one of yours?
It's a plant. A priori knowledge of failure domains. So this is a thing that I harp on a lot, is this free-form expression of the current state of things, right? So we say to developers, send me your metrics, all of your metrics. Send me your log message, all of your log messages. And so what they do is they log and metric everything, right? They're oh, well, I instantiated an integer. I think I'm going to make a metric around that. I have 27 billion integer assignments right now to date. And it's like these horribly useless metrics, right? So if you have billions of lines of logs, I'd say that you probably have a logging problem. If you even have a priori knowledge of the content of those logs and their association with failure domains, I would say that you need like a stream processing system for those logs that gives you comprehension of each and every single log message that comes through. Like, if you're logging stuff that's not being analyzed in some way, you're logging wrong. Like, you're logging things that you're paying for storage for, you're paying for processing for, that's just like, it's just bits, right? Like, it's bits that you don't need, that nobody can take action on, that's just pointless. It's pointless bits. They're warm, fuzzy logs, yes. If I log things, it'll make me feel better. I'll be able to sleep at night, because I know tomorrow when I get in, I can look at my logs. Except that the problem is you're doing like this ex post facto adding of logs and metrics every time something breaks. So, oh my God, I have an outage. Well, if I had known how many integer assignments were in my Go routines, I could have prevented this outage. And so you add a metric for integer assignments in Go routines. Except that that wasn't the problem, right? Like, that wasn't what actually caused it. And the key is, again, understanding these are my failure domains. These are the things that are going to really break things. And then having logs that are processable. So yeah, it's a whole lot of purposeful logging as opposed to reactive logging.
I do a little bit of reactive logging, though, from time to time. I use it like exploratory logging. Sometimes it's rather difficult to figure out what at all is even the domain. Like, there's a failure that we thought we were aware of. Like, is there a way we can just see whether something else somehow like pegged memory right before then for some reason? You know, I don't expect that things that I'm not actively using on the system are going to do something wrong, but I'm certainly not getting a log out of any of the things that have failed. So things like that sometimes are where you just sort of turn on the spew and hope that an error happens and then just regex your way through until you see it. After that, though, ideally turn off the stuff.
Yeah, and yeah, I guess like if you're not doing like real-time signal processing on all of your telemetry and logs, like at least make sure that they're indexed and searchable and that you can do like intelligence analysis on them, yeah.
So building on that, so we're getting billions of rows of data that weren't available, we didn't care about in the past, logs and events and metrics and various things like that. And yet, you know, Termi and I were talking before this, and Greg already mentioned on the panel that, you know, this notion of auto remediation is something that makes a lot of us pretty uncomfortable. Question for you guys is, will there be a point in the future where the right way to rationalize all this data that we're collecting is to do machine learning-based anomaly detection, and will there be a point where we'll trust machines to actually make some decisions on our behalf if there's some confidence level that we have in the recommendation of the machine?
I'd have a hard time believing it would become that complicated of a problem. Perhaps at a very, very large company, I could see where there are systems in place that are sort of magical state machines that humans don't understand. But for the most part, most of the ops people I've met have been humans, and they write pretty similar standard things that they have a little script for they can check on. They have a way to check whether the thing is up, and it's usually something very simple like, does this respond? And for the most part, those are what I think I would see going forward for a long time. It's been happening for the last 20 years. I suspect it will probably happen for the next 20. Machine learning stuff is very interesting. It takes a lot of effort to train sort of the brain for machine learning. You have to give it a lot of information, good learning, like good quality algorithms and things like this to decide. And really, most of the time, pinging is the answer. So it's difficult to convince somebody that they're going to go through all the effort of doing that for their monitoring. Now, there's larger places, I think, that are definitely have a much more complex problem because they have more interconnected systems. Once you have a lot of interconnected systems, so everybody's doing microservices and things like this now, there's more interconnected systems. it's approaching the system where there's starting to be a little bit more state machines kind of going on because you're not really sure how all these things will work together. I could see that. I could see that becoming more of an issue. It would be awesome to be able to just spew log everything and have something tell me when something is happening. It's possible it'll do it. You know, I don't know when, but I also think that a lot of other amazing things are happening in the machine learning space. So who knows? For me, I would not like to have a system. I would not like to write a system that's too complex for me to monitor with HTTP requests, basically.
Yeah.
Personally, that's what I would like, but I agree that a lot of people are in situations where that's no longer possible.
Oh my God! Don't bring DJ Bernstein into this conversation, please. So,
/ SRV.
oh my God! No, kill me. No, I like daemon tools actually. Anyway, so
Except for that fucking time format.
look, don't. Anyway,
Pipe everything through.
it's the only. No, there are many sensible time formats. I prefer epic time. I just want an integer counter, please. No, so yeah, auto remediation is a thing that scares people, and this is because they don't trust the judgment of machines. And what I think the reason that people don't trust the judgment of machines is because, yeah, well, but okay, but here's the thing, it's like a matter of self-trust, right? Like I say, let's say I have a service, right, and I have a health check for it, and it's like get/health, and if it returns 200 okay, then I know that the service is okay. And I know, like, because we all know that when you just like restart a service when it's in a weird, funky state, it goes to a clean state. And I'm not going to say that it can't get back into a funky state, right? Like if you have some periodic behavior that causes a service to repeatedly get into a funky state over time, like if there's another service that's every 30 seconds calling this service with a bad API request, right? That you just
Restart every
code.
29 seconds.
Yeah, restart every 29 seconds. No, but the point is that auto remediation is like, it's not like people think of it as the tool, right? But really, it's like the wrench in a toolbox full of wrenches. Like it's not the end-all, be-all of things that you do. You understand that there is a failure. There's a type of failure, and in order to remediate that type of failure, you take a specific action. And you take that specific action over and over and over again because it happens so infrequently that it's not worth fixing. Some bugs are not worth fixing. You encounter them so infrequently that you can just restart the machine at 2 o'clock in the morning or even at 2 p.m. during the day if you're working on something more important. So what you do is you just say, okay, well look, I accept that this thing happens, and I'm just going to tell the monitoring system when it happens, it's going to restart the service for me, right? Because I'm just pushing the button every time. I'm just texting my automation system restart every single time it fails. So instead of doing that, instead of wasting time doing that, you just automate it. But the trick is understanding how frequently that automation happens, understanding how big of a problem it actually is. Without that understanding, without comprehending the nature and the magnitude of the problem, you don't understand what the problem is and if you should address it or not. So that's what I would say to people that are contemplating automated remediation, is that do it. First of all, do it, because you're just waking people up at night for no good reason. And then 2, understand it.
To categorize the nature of your issues.
Yeah.
So you understand it well enough to be able to prescribe what to do when specific categories of issue occur.
Yes.
And
Exactly.
I would add in, be very comfortable in what happens when you kill a server.
Yeah.
Like, as long as you're very comfortable that when a new one comes up, it'll be in a good state.
Right.
You can sleep a lot better.
That's the thing that happens.
So a lot of
too.
people do not have that. Like things not joining, like nowadays we have tons of clustering software, which is great. It'll find and join a quorum and figure it all out and like add itself back to the cluster. That was not always the case. But you want something like that. Otherwise you will rapidly Yeah, you're starting new problems by restarting it, right? So write everything in such a way that starting a new one solves any problem it had.
Yeah.
Until it gets the next job from the queue that kills it.
Yeah.
So we're awash in tools these days more than ever. So we've come a long way since the days of the Google Perl script or the cron job. In fact, at BigPanda, we do this thing called monitoring scape, just out of curiosity, really to help ourselves, our own ops team. We wanted to see what the variety of tools was that were out there, and we pretty quickly got to about 100 different tools that are in routine use. Question for the two of you and for the peanut gallery, what's the one tool in your stack that you can't live without that you didn't write?
Oh.
Refer to the last clause of my last sentence.
He works for us. So.
Yeah.
Let's see, tool in my stack. I don't know. I feel like it doesn't count if it's like the only way to interact with someone's API. So for example, nowadays we have to use we're using Kubernetes for a lot of things, and our only way to interact with that is kubectl for the most part.
Well, but Kubernetes.
Yeah.
You didn't write that, and that's a part of your stack. That's a tool, right?
Yeah,
You made a choice to use Kubernetes.
Yeah, we made
Yeah.
a choice to use that over a couple other options.
Why?
Yeah.
Why is it indispensable?
Well, at this point, it'd just be really shitty to switch. But I mean, it does a lot for us, right? So it's something that we started off with CoreOS. Fleet turns out to not have a future or whatever, and so Kubernetes is the next step up on scheduling, and we wanted a scheduling thing. Nobody wants to manage processes, and me least of all. So yeah, Kubernetes. Now we manage Kubernetes processes.
A smaller subset of processes you have to manage.
Somewhat smaller number of processes.
Greg, how do you feel about CoreOS?
Oh, God. I have 5 talks about how I feel about CoreOS.
I quite enjoy CoreOS personally, but yeah, Fleet has not been anything of use.
I really like CoreOS, actually. So, okay, I did a talk at the Advanced AWS meetup this week, and I got a lot of questions about, if you had to do it all over again, would you still use CoreOS, or we use ECS, Amazon Elastic Container Service, EC2 Container Service? I don't know what it actually stands for. We're going to call it ECS. So that's the thing that we use. It's Kubernetes, right? That's the thing that we use that's invaluable. It makes everything, I hate deploying services, and I want somebody to do it for me. And ECS does that for me, and it does a lot of really good things for me. But I got this question, would you use CoreOS again? And I hemmed and hawed for 5 minutes on this question, but the answer is yes. And here's why. And it's because it's this forcing function. And I keep saying forcing function because Cliff has said forcing function to me so many times. It's this thing that forces you to rethink the way you think about infrastructure, because no longer does SSHing to a machine make any sense. Every single machine in our fleet is identical. They all run the exact same configuration of CoreOS, with the exception of the machines that do our etcd quorum. They're not a special snowflake. They're just a different configuration of CoreOS. But yeah, all of our compute nodes are exactly the same, completely identical. And so it takes this idea of kill your darlings and it institutionalizes it in CoreOS. And that's the thing that I like. And so yeah, I'd continue to use CoreOS because it abstracts away the concept of managing an operating system for me. So that's, in general, how I feel about CoreOS.
The cool forcing function for me there is that there's no package management on it.
Yeah.
So people
install
SSH
shit.
in, and then they're like, well, how do I fix this? It's start with a better place, start from a better place. Figure out what's wrong and then make a new one that doesn't have that problem anymore.
Yeah.
And so, yeah, usually it's you run some Docker container or something that has some arbitrary tool for you to fuck with. But in general, I like the idea very much that no, you're not going to change the base system. All you can do is run things.
Yeah, well said. So as a community, we get so wrapped up in the current development paradigms, the current operational paradigms, and today it's containers and it's microservices and whatever it is that we're currently invested in. A question for you is get a crystal ball, polish it up a little, and tell me, if we are to ever evolve beyond, call it, DevOps or whatever cliche you want to apply to it, but to a world where there truly is no ops, there is smart automation, there is kind of self-healing systems. What does the stack look like? What do our roles look like in a world where we think about kind of self-healing tools, no ops?
Okay, I can pie in the sky a little bit. So imagine your init system is only a port on which you can spawn processes that all themselves have their own port. So everything, or IP at this point, we have IPv6 if anybody can figure out how to right share IP. Everything is directly addressable. It provides its inputs, outputs, and everything via, let's say, TCP or whatnot. And that is the entire way that you interact with everything. There's no local file system. There is simply a endpoint with which you interact. Some of them have better latency than others, perhaps, because you co-locate them. But in general, the only way things interact is through IPC via a networking thing. It's kind of Erlang-y, probably, I'm guessing. But but basically, yeah, something of that nature. So I would say that would be the next thing. So your interaction with remote things is the same interaction you have with local things. Monitoring becomes basically shell scripts for anything. And I think we're moving towards that as the paradigm, as the way people interact with things already. Everybody already wants to sort of treat everything as if I'm just managing local processes or managing whatever. You have so many tools available to you to do that. So really the next step is just to make that actually true, rather than wrapping your infrastructure on that, have actual sort of ubiquitous computing or whatever, and just not care where anything is running, besides locality of data and or latency. Don't know how that has to do with monitoring, but
I'm gonna need you to sell my product more.
Oh, I don't know. Is that what you were doing?
No. Yeah. Oh, okay, so I'm gonna say something that may be off-brand. I want monitoring to go away. I literally want to automate myself out of a job and everybody else that does monitoring out of a job.
I guess everybody in general.
Yeah, that's basically, well, no. So when I joined Opsee, I did so because I wanted to build a thing. And I didn't want to have to do all the stuff I had done before. I just wanted to work on a product, right? And I think that ultimately that's what everybody wants. And I'm talking about like even people that are in DevOps, right? Like you're talking about an infrastructure product. You're talking about a product that you use that you build, that developers at your company use, right? Like that's DevOps. And so like what I'd like to see is I want a place where I can just put my code. And I'm going to go real far in the future. I want it to like self-replicate, right? Like I just want to spawn my code somewhere in a computer. And then whenever it's overwhelmed, I want it to spawn more instances of my code. And whenever I make a change to the code, it's like data. And it's like this system is eventually consistent like a distributed data store is. I say, I want to make this change to my code, which is really just data, right? Like code is data. So I'm going to make a change to this giant data set, and it's going to replicate, eventually consistently throughout the entire set of processes that are my product. And like, the thing that's cool about this is like, where does monitoring even come into play? Well, it's part of the product. Like, it's a first-class citizen of everything this product does. It has to be aware of when it's overwhelmed so that it knows to scale. It has to be aware of when there's a fault so that it can self-correct. And that's like, I want monitoring to be not monitoring. I want it to be part of the thing you're building.
Instrumented into the code.
Yeah, exactly. I want self-reactive code. I want code that's introspective, right? And I mean, I know, like, if we're going real pie in the sky, that's what I want. If we're going realistic, then what I want is like, and this is all Faye, actually. I steal a lot of ideas from her. What I want is like, I want a container, like a container ship, right? And it
Try
has,
Docker.
I've heard about this Dockers thing. I
Watch
own
out, it
many
bites.
pairs of Dockers, but there's apparently that's not the right Docker. No, but like, what I want is I want to have like my product, right? And it's like this thing, and it has ports that come off the side, and then I can like plop it into place, and like the log port connects, and there's a standardized interface, like OBD2 readers in cars, right? Which is like, to the chagrin of car manufacturers, like, well, this is actually a terrible standard. And I'm saying that we can maybe come up with a good standard. But anyway, like, everything sort of reacts similarly. And so whenever I like plop a thing in, I know what to expect coming in and out of it, and that's like, I think, the next step. Like, I don't want to have to run EC2 instances anymore. I don't want to have to run a Kubernetes or an ECS cluster. I just want to say, look, here's my container, and these are my like defined inputs and outputs and failure domains. Just like run this thing for me, and I want it to be done.
So at Wercker, we have a little bit of like a practical solution to sort of part of that idea. The idea being that, let's say this thing goes down or something, but people still want to use it. It sort of comes from the open source idea that is, the best way to back up your stuff is to publish it so that Google makes like 1,000 backup copies of it. Our stuff all runs beyond our service. It also can just run locally on your machine. So if for whatever reason we are down or too slow, you could also just run it.
Yeah.
So it's sort of like should you be like an active user of it, there can't really be downtime as long as we make that experience easy enough for you. And there's definitely things that are still on their way for making that experience good and better, and even more like what you'd experience just with the website. But at the same time, if everybody just already has a copy of your code, whatever code it may be, they don't have to worry about your service going down. They have it locally. And if everybody sort of shipped with like a free connection to all the magic like stuff on the internet that they had a copy of, then there's really no reason to have to talk to a lot of things except when you're sharing information. And obviously we all still want to do that. But in the case that like you're partitioned for some reason, you just go to your like local neighborhood part of the internet, copy of the internet, and run any services you might need. And I think that's a world that could very easily exist. It's well within our sort of peer-to-peer like hierarchical like skills. We've been making a lot of things like this over the years, and shift the onus of control to the user rather than to some server somewhere, and you're in the money.
Yeah, I think that like a reasonable next step as far as monitoring concerned is just like to have people, again, understand what your failure domains are, but then to publish like the state of those failure domains in like a consistent way, right? So one of the things that we do is like you can expose an HTTP endpoint that says like these are the things that I depend on and this is their health, and then we can look at it and say, oh, well, it looks like everything's okay, right? And I think that just the thing that's so amazing to me is that this isn't an idea that occurs naturally to people. Like it's a thing that you have to tell people, look, if you just tell us how things are going, we can help you in a lot of different ways. So I think that just getting people into the habit of understanding how things can fail and then really just tracking that's like the next step on my like grand dream of things being amazing.
Okay, so we could continue this for a long time, but we also committed to getting you out of here before dawn. And a round of applause for Termi and Greg. Thank you to all of you for coming.
Clapping for everybody.